8.5, line of best fit equation. If you draw a line of best fit, it is possible to determine the equation of the line of best fit. You will remember that the equation of a straight line is given by y equals mx plus c. M is the gradient and c is the intercept. Or you might have seen this at y equals mx plus b. Either way, that variable, the final variable, is the intercept. Okay, so gradient, m, as we can see right here, is rise over step or rise over run. Okay, so the amount that you go up divided by the amount that you go over. Okay, y over x. So the change in y divided by the change in x. That's where the term gradient comes from. So, and of course the intercept is where it crosses the y-axis. We'll look at this with an example. The points with coordinates 0, 6, 2, 7, 4, 8, and 6, 9 lie on a straight line. Draw the line and determine its equation. Okay, so first we are going to put these points on to this graph right here. 0, 6, 2, 7, 4, 8, 4, 8, and 6, 9. Okay. So they're all nicely together, and we can join these using a line. Maybe I'll use that one right here so we can go like this. Okay. Okay, so we need to find out y equals mx plus b, which means we need to find m or plus c, whichever variable, and we need to find c. Okay, so c is pretty straightforward. It's where it crosses the y-axis. Okay, this is the y-axis and this is the x-axis. So where does it cross y? It crosses at 6. Okay, so from looking at the graph, we know that y or c equals 6. Okay, because y is 6 when it crosses right there. Okay, now m is rise over run or rise over step. Okay, so we're going to look at the graph and we're going to get these. So what we need to do is pick any point really, and we're going to move up over to that point and figure out how far it is. So we can use this dot right here. If we start here, okay, and we go up 1, that's our rise, okay, 1. Then our run to go over and get back to the line is 2. 1 over 2. So it would be 1/2 in this case. We could look at it anyway. We could start here and then go to this one, right? So our rise would be 2. Okay, in this case we'd go up 2, and then our run would be 1, 2, 3, 4. Okay, so rise divided by run. So in this example, it would be 2 divided by 4, and of course 2 divided by 4 is also 1 over 2. Okay, so it gives us the same answer. We can start anywhere as long as we're moving forward, then we'll get the correct answer. So if this was pointing down, right, then our rise would have been down, which would have been negative. So we would have had a negative number. Here it's positive because we're going up and we're going to the right. So we have m, we have c. We can put those into the equation, and we get the equation of this line of best fit. Y equals 1/2 x plus 6. Example 2. Alright, so we already have a scatter plot here, and we already have the line of best fit. So here's the data, it's been plotted, and then we have this line of best fit in between. Okay, so determine the equation of the line first, and then we'll answer a couple questions. Okay, so again, we want to find y equals mx plus c. So we want to get c, and we want to find m. Well, c is simply the intercept. Okay, so right here, it looks to be very close to 5. Okay, so we're going to write down 5. Now m, the gradient, is rise over run. Okay, and so it's convenient to pick points that are sort of just crossing so that we don't have to use halves or quarters. Alright, so let's pick a point to start at that's very, so this one's very close to 6 and 8, okay, very close to crossing over, and right here this one is also very close. Okay, so we can use these 2 points to figure out our rise over run. So rise, we go up 1 and 2, okay, 8 to 10 and then to 12, so we go up 4 units. Okay, we have to make sure we look at the scale. We go up 4 units, so our rise is 4. Now our run, It's going to be pretty long. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we go over 8, and the scale of this bottom is 1 for every one of these, so it's actually 8. So it ends up being 4 over 8, which simplifies to 1 over 2. So it's actually the same as example number 1. So we can write our equation as y equals mx plus b, so that's going to be 1/2 x plus 5. Okay, so use the equation to estimate y when x equals 4. So we're going to have to do some substitution here. So when x equals 4. Okay, so we want to calculate, well, what's y going to be? So this was A, now we're working on B. Well, x is 4, so we're going to sub that into our new equation. So we have 1/2 times 4 plus 5. 1/2 times 4 is 2, right? 4 divided by 2 is 2, plus 5, and 2 plus 5 is 7, okay? So we're saying when x is 4, y equals 7. All right, well, let's check. When x is 4, y equals 7. Yeah, that is confirmed by this graph. That looks very similar. When x is 4, if we go up here, right, and then we go across, it is very close to 7. All right, so that works. Let's estimate x when y equals 18. Okay, so this one's going to be a little bit harder. We're going to have to do some algebra. So when y equals 18, let's find x. All right, so we're saying y is 18 equals 1/2 x plus 5. That's our equation. Okay, so we're trying to figure out what's x. How can we solve x? All right. So we've got a 5 on each side. Sorry, we have a 5 on this side, and we want to figure out what x is. Okay, so if we subtract this 5 from the right side, then we have to also subtract it from the left side. Okay, so 5 minus 5, that's gone, right? That's 0. 18 minus 5, that's 13. So 13 equals 1/2 x. And I did that just to make it a little bit easier for us to figure out, well, 1/2 times what value equals 13? Right? 1/2 of what equals 13? And the answer to that is 26. Right? X equals 26. So when y is 18, we've used our equation to find out that x equals 26. Okay, so let's confirm this. When y equals 18, so that's way up here. Okay, when y equals 18, we'll follow it all the way over. I mean, the line isn't even extended all the way. We would have to extend this. When y equals 18, we're saying that x equals 26. And if you follow this down, we're actually very close. We get 25.5. But of course, you know, this is an estimate and it's not going to be exactly perfect. But 25.5 is very close to 26, which is what we calculated. So once you have your equation, you can plug in values and figure out what x or y is from your equation.